What's up, Math 8? Thanks for tuning in for another episode of Math with Mullins. Today we're looking at our quiz review for lesson 6.1 through 6.4. So these are the 6 things that this review goes over. We have product of powers, power of a power, zero exponents, power of a power, quotient of powers, and negative exponents. This is all from your notes, so you should already have this in your math notebook, but if you didn't see these already, you might want to take time now to pause this video. Otherwise, let's go ahead and get started and try some examples. So the first ones, we're just using products and writing products as exponents. So this is a -3 in parentheses, and there are 1, 2, 3, 4, 5, 6. So -3 in parentheses to the 6th power, that has to be in parentheses for it to work. The next one, I have 4, 5, so that's 5 to the 4th times 1, 2, 3, 4, 5, 6 y's. So y to the 6th. Number 3 starts with the evaluation section. So 6 to the 3rd is 6 times 6 times 6, which is 216. Number 4 is -2 to the 5th. And notice that -2 is in parentheses, so I need to make sure all of my 2's are negative. And if I work this out, I'm going to get a -32. -4.8 to the -7th times -4.8 to the +7th. Because these are the same base, I can use my power, my product of powers, so I can just add those two together. So initially I would get -4.8 to the 0 power, because -7 plus +7 is 0, which is equal to 1. I'm still going to start evaluating here, except now I'm going to focus on PEMDAS. So let's make sure we're doing order of operations. The first one, I'm going to do 5 to the 3rd minus 4 to the 2nd. That's 125 minus 16. 125 minus 16 is going to give me 109, and then I will multiply by 3, which gives me 327. For number 7, 1/2 to the 3rd power, that'd be 1/8, plus 5/8 gives me 6/8, and I reduce that to divide by 2. I'm going to get 3/4. Okay. For number 8, I need to start with my absolute value. So 4 to the 3rd, that's 4 times 4 times 4. That'll give me 64. Plus 2 to the 5th is 32. 64 plus 32 in that absolute value gives me 96. And then 96 minus 8 gives me 88. Okay. Continuing to evaluate, just again using that order of operations. So starting small here with the parentheses, 4 to the 2nd is 16 and 3 to the 3rd is 27. Then I'm going to add 16 and 27 together. So 16 plus 27 gives me 43. And then I'm going to take that and multiply by -1/2. I initially get -43 over 2. You can reduce that and divide that, and you can say it is -21.5. Or if you leave it as -43 over 2, I'd still count that as correct because it's in simplest form, and nothing else can be simplified there. Next up, you can do one of two things here. I started on the inside of the parentheses first, and then I squared my answer. So 16 times 16 is 256. 15 times 15 is 225. So I'm going to take 256 and subtract 225. 56 minus 225 is 31, and then I take that and square it. 31 squared gives me 961. You could have also distributed this to both these exponents and made it 16 to the 4th minus 15 to the 4th, and that would still work because that's using your power of a power. Simplifying the expression, the first one we have is 1 over 4 to the 2nd power, because initially you might have done 5 minus 7, and that'd be 4 to the -2nd power, but then we want to make sure we make that positive exponent. Here we can subtract again. We get 8 to the 3rd normal positive exponent. For this one, I added my exponents on top first, then I subtracted, and I got 6 to the 8th. Okay. Next up, simplifying the expression. Again, for this first one here, I kept pi to the 15th on top, and then pi to the 3rd, pi to the 9th is pi to the 12th. Then I can subtract my exponent since I have the same base. I'm going to get pi to the 3rd. for this one, number 16, 3 without an exponent is like 3 to the first, and I just add those together and I get 3 to the ninth. And then for 17, I'm just basically doing 5 times 3 is my exponent, so that's a to the 15th power. For number 18, simplify the expression, write these answers as your power. This will be 3 to the 4th, c to the 4th. For number 19, I should get negative 2/7 to the second and p to the second. It's super important that negative 2/7 is in parentheses because you do want to make sure that fraction gets the 2 for both the numerator and the denominator, and we want to make sure it's still showing as negative. The next one down here for 20, I just added my exponents on top first, so x to the 13th plus x to the 9th is x to the 22nd over x to the 12th, and then I subtracted, I got x to the 10th. Some of you, though, you found that x to the 13th over x to the 7th is x to the 6th times x to the 4th, and you still can get x to the 10th. Either way is fine. For 21, writing your answer as a power, we want to make sure 8 stays on top, but d to the 6th has to move to the bottom because that negative 6 belongs to the variable d. And then here for 22, I still subtracted, and I got 12x to the negative second over 4. That x to the negative second is going to go down here with the 4. And then the last thing I can do is divide both of these by 4. 4 divided by 4 is 1, 12 divided by 4 is 3. So now my final answer for 22 is 3 over x to the second. 23, very simple. That is just going to be 1 since everything to the 0 power was distributed, and we're going to get 1. The last one, it says a one-celled aquatic organism called a dinoflagellate is 1,000 micrometers long, and 1 micrometer is 10 to the negative 6 meters. So what is the length? We're going to be taking that 1,000 and multiplying it by 10 to the negative 6. However, we need to make sure they're in the same, having the same bases. So what I did is I changed 1,000 to be 10 to the third times 10 to the negative 6, and then I simplified it from there. 10 to the third times 10 to the negative 6 is going to be 10 to the negative third, or 1 over 10 to the third, and then you can reduce that even more to be 1/1000. Okay? That'll conclude our quiz review on lessons 6.1 through 6.4 with all of our exponent rules and properties. Hopefully this helped you just get an overview of what you're going to see on the quiz. Good luck tomorrow, and we will catch you next time. Have a great day.